Hi, my name is Mike Theiss, and I teach my face-to-face classes at the University of Wisconsin Marathon campus. I also teach for the University of Wisconsin online campus. I will be working with you in an application called Microsoft Excel.
Now we're going to talk about fitting data to a nonlinear data. And what I've plotted here is the position of my free fall particle as a function of time. And again, it should follow a path of approximately 1/2 gt squared, or using the acceleration due to gravity 4.9 times t squared. Okay, so again, I'm going to add a trend line. So I'll right click on this data. Okay, then I'll go to add trend line. Okay, and you can see it. The default is always to throw a linear line in there, but you'll notice when I display my equation, my r squared value is 0.95, which is not exactly the best correlation factor that we're looking at. So what I'm going to do is I'll just go through these different ones. Exponential, that would be when I have e to some power. You can see my r squared on that is 0.91. Logarithmic, that would be where I have a natural log in there. You can see that is really not very good at 0.767. I'm going to skip over polynomial. I'll come back to it. And you see, oh, bam, there's power. Okay, r squared value of 0.9999. And that's 4.81 times x to the 2.0028, and you can see that that's very close to the 4.9 t squared that we're looking for. Again, remembering that y is position, x is time, so to relate back to these variables right back here. Now, I skipped over polynomial. You want to be very careful with polynomial. I'll click on here. You see I get a very good curve, and you'll notice that the curve on a second order polynomial, which means it's going to be x squared and so on, I get the 4.9x squared and then some small numbers after it, which leads me to believe, hey, I've got a very good fit with an x squared. You'll notice as I increase my order 3 means x cubed, x squared, x, so on. Then I get x to the 4th. I can go all the way up. I can get up to order 6, and you see that I have a perfect fit. That's what an r squared equal to 1 means. That means my data goes perfectly through all these points, and you're saying to yourself, wow, so that must be the equation for a free fall particle. Well, how do I know if that's good? Well, let's see what happens as I move forward, because yes, this might fit the 8 points that I have here, but what happens if I get a 9th point? Okay, and what I can do down here is I can forecast my forward in my data by half a period, which is basically another second, because here I have a period of 2 seconds. And you'll notice that this data no longer, I don't expect the particle to reverse directions on a free fall and move back up, which is what this data is telling me as I move forward. So even though my r squared value is 1, that doesn't necessarily mean that's the best fit for the data. That's not going to necessarily model my data perfectly. If I want to know something before or after the data, that may not be good. I go back to a power with this forecast on it, and you see that it keeps following along the line that I'm expecting. So this is a good fit. 0.9999 r squared value is excellent. And that's how you fit a nonlinear curve, and being careful with the use of the polynomial.